Look at the field energy in a given system, in a given electrical mechanical system, where this is a movable object attached to a spring, this is an immovable object attached to a coil. We can derive the expression for the field energy. Now, in this system, when it's stationary and in equilibrium, we can see that, of course, the mechanical energy is equal to 0. So the incremental mechanical energy is also equal to 0. Then, according to the equation that we saw in the previous part, we have that the incremental field energy is equal to the incremental field to the incremental electrical energy. Now we can write the incremental electrical energy as this. It's the voltage times I over time. And the voltage is just the flux over time. And so if we combine these two together, we can get an expression for the field energy, for the incremental field energy, that's equal to I times delta lambda. So the field energy is just the integral of this and so we have the integral of I times delta lambda. Now this equation is very handy. We can now derive an expression for the magnetic for a magnetic system. Now let us assume that we have a magnetic intensity in the core, in the air gap, and magnetic intensity in the core. The length of the air gap, Lg, and the length of the core, Lc. Now we know that I, the number of turns, n times the current, must be equal to the magnetic intensity of these two times their respective length. So we have this Ni times Hg is equal to Hg times Lc plus now we know that the number of turns times the current is equal to Hg times Lg plus Hc times Lc. And so the current is just this term over here divided by n. Similarly, we know that the flux linkage lambda is equal to number of turns times the flux. And the flux, we can write it as the cross-sectional area times the flux density. Now if we combine these two values in this equation, we have another expression for the field energy. And that's simply Hg Lg plus Hc Lc divided by the number of turns of the coil times Na dV, because we have the derivative of lambda. Now let us assume that Hg is equal to B over mu 0. We can then rewrite this equation as Wf is equal to Hc times Lc times the area times dV plus this one, B of mu times Lg times A times dV. The integral of this one. Now if we look closely, we see that this is nothing more than the volume of the core, and this is nothing more than the volume of the air gap. So we can write this as the integral of Hc dV times the volume of the core, and this is B over 2 divided by 2 mu times the area times the volume of the air gap. And so we have derived an expression for the field energy